Hey there, all you cool cats and kittens. Today we're looking at 45, 45, 90-degree triangles. So we're talking about special right triangles. Tomorrow we're going to see a different type called the 30, 60, 90. In looking at today's, so we're all about 90-degree triangles. So we've got this one here with a 90-degree angle, 45 up here. The other one's going to be 45 because remember, everything needs to add up to 180 degrees. So 45, 45, and 90 adds up to 180. Now the reason we're looking at these is because we can solve the sides a lot faster on these special cases. Again, across from the 90, the longest side, the most important side, is the hypotenuse. Remember the other sides? We call these legs, and in the case of these ones, they're the shorter leg. So across from the 45 is a shorter leg. But if you notice, across from 45, that one opens up, makes a short leg. The other side's also going to open up and make the same size side. So we'll also call this a short side leg. Sorry. All right. So we talked about what's across from each other. We have a 45-degree angle. Across from that is the short side leg. We have another 45-degree angle, also called the short side. And then the 90-degree angle across from that is the hypotenuse. You'll notice that both short sides are the same. So what we're going to focus on today are the ratios. So going down this row is always going to be the same. We fill out these tables the same way for each problem. X, this side is the exact same, so X. And then for the hypotenuse, it is X times the square root of 2. Over in the last column, once we get to our problems, this is where our answers are going to be, or the other side lengths. All right, so let's jump into a problem. Our first example, they're going to give us a 45, 45, 90 degree triangle. So 45, 45, 90. They'll give us one side of the triangle, right here, 7. And it'll say find the missing sides of the triangle. Okay. So since we see it is a 45, 45, 90, we're able to set up the same table from above. So I'm going to go ahead and draw that table. So we always have two short sides of this triangle and one long side called the hypotenuse. And down the middle are the ratios, and those never change. It's x, x, and x square root 2. Now looking back at the triangle, we're only given one side, this 7. We need to find out what the other two are. So we want to figure out which one that is. That 7 is across from a 45, so this is a short side. So let's go ahead and plug that in anywhere we have a short side. So on our table here, this 7 is a short side, so we'll go ahead and put it right here. So that tells us that x is 7. But if we know one of the short side is 7, the other short side is the exact same thing. You see x equals, so both of these sides are 7. The great thing about that is, now that we know what x is, we can take that x value and plug it in. So in the last one, instead of x, we're going to plug in this 7 square root 2. Now it doesn't make too much sense to us on that last number. If you really want to, you can take your calculator and turn that into a decimal to see what that is. And looking at our calculator, 7 times the square root of 2 is about 9.9-ish. So we have three sides here, 7, 7, and 9.9-ish. And that looks like it works out because on a right triangle, that hypotenuse should be the longest side. And there we go. I'm fine with this. These are your three answers. You got 7, 7, and 7 square root 2. So depending on what they give us, that's where we'll start on the table. So let's see another one. So, for example, we're going to do that same setup. We have a right triangle. Again, it's 45, 45, 90. And they're going to give us 7 again. The only difference this time, the 7 is now across from the 90, meaning that this 7 side is the hypotenuse. But we can still fill out the table. The first two columns are always the same. Short side, hypotenuse. And down the middle are the ratios, x, x, x square root 2. Alright. So again, we find what we were given, the 7. But this time, that 7 is the hypotenuse. The hypotenuse is the third row right here. Alright, third row. So 7, never ever change that. That goes in this box. That is the hypotenuse. I need to find out now what the short sides are. You notice those ones are what x equals. Down here, I can take that and make it into an equation real quick. X times square root 2 equals 7. And we're going to pull that out of this table. And let's solve for x. And once I know what x is, I can put it up here. The square root 2 is connected to the x by multiplication. So we can divide it off. But what I do to one side, do to the other. So x equals 7 over square root 2. So for right now, the x is by itself, so we're going to go ahead and go with that. And aren't there two boxes up here that ask us what x are, or what x is? Yep. So the short side, x is the 7 over square root 2. And I know that the two short sides are the exact same length, so 7 over square root 2. And again, if you wanted to make sense of it, you can find these out as a decimal. 7 divided by square root 2 is about 4.9, and those two sides should be smaller than the hypotenuse, which is 7, so it looks like it's good. And if you really wanted to, you can check these by using Pythagorean's theorem, a squared plus b squared equals c squared. If you want to check all these out, where this is a and this is b and hypotenuse is c. Alright, let's get to some trickier numbers. So another right triangle. Again, it's 45, 45, 90. That's all the ones we're going to see today. We make our table. So automatically when we see 45, 45, 90, we can say it's going to be a short side, and a hypotenuse side. The ratios down the middle never change for these. It's x, x, x square root 2. This time they give us one side. It's going to be the 3 square root 2. And looking at its placement, it is across from the 90, meaning that this is the hypotenuse side. And when it's the hypotenuse, it's going to go in the bottom box, 3 square root 2. We need to find the other two sides, the short legs. So what we do is set it up and solve for x. So x square root 2 equals 3 square root 2. And just looking at that pattern, you can kind of tell what the x is going to be. If not, just divide it by square root 2. And that square root 2 cancel out. So x is 3. And there's a box that's asking us what x is. So x is 3. And same thing here, x is 3. Alright. One last example, and then we're done with today's notes. Guess what? Right triangle. 45 degrees. So even if they don't give us the other one, we know that if one's 45, the other one has to be 45. So anytime I see a 45, we're going to set up the 45, 45, 90 tables, short side, hypotenuse. Down the middle, always, 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 x, x, x square root 2. And let's see, this time they give us square root 8. Okay, so we want to see which side that is. Short side, or a hypotenuse. We see what it's across from. It's across from a 45. That means it is a short side. So no matter what it is, I'm going to put that automatically into the table. So short side, square root 8. Now the good thing is the two short sides are the same size. So square root 8. Now the last one, it says take x, which is square root 8, and connect it to a square root 2. So what we have is square root 8 times square root 2. That comes out to a square root. 8 times 2 is 16. All right. Or if you want to look at it like this, you have 8 times 2 inside, which comes out to square root 8, square root 16. And then the square root of 16 is a 4. So we found out that our hypotenuse side, after all that math, is a 4. All right.